Hi everyone and welcome back to our channel. I am Tiru and I'm so excited to have you here with us today. To start with, it's not easy for a working engineer or a fresher to crack Java interviews since they usually involve a wide range of topics like core Java, frameworks like Spring Boot, databases, APIs, microservices, design patterns and many more. Such that even for experienced web developer, it will take some time to cover all the topics and cracking the backend Java interviews. If you're struggling and feeling frustrated trying to crack a Java backend interview, don't worry, we have got you covered. In this exciting new series, we are going to explore the world of Java and backend web development topics, focusing on real-time interview questions faced by actual candidates. You heard it right here in bitbee. We're not going to conduct any mock interviews. We will just focus and explore the questions asked in real-time interviews to the candidates. By myself, I am collecting the questions from the candidates and bringing the solutions for them for you. I am also requesting you to participate by submitting any interview questions you find important or that you have been asked by interviews to support fellow community here. You can send your collection of questions to the email showing on the screen, or you can also fill the form I have provided in the description. It's a Google form and you can fill all your details and the interview questions there. Based on your opinion only, I will reveal your name or the company name in this video, else no. Also, if you have any queries still, please mention in the comments. Kindly don't hesitate to help the community. This is how we can grow together, and thanks for all your support. Please kindly subscribe to the channel if you are not yet subscribed and share it with your closed ones. This might be helpful for them. So coming to the today's very first episode of this series, I have collected these questions from one of my friend. These were asked in gap for 5+ years of experience in Java. Let's dive into the questions without making any more delay. So the very first question is which Java version you are using. Yeah, it's easy and straightforward question. You can answer with whichever version you are using. But wait on, then there is a twist and combat of questions are coming to you now. The intention of this question is to test you really work the features of the version you are using, or to test you whether you are really following the recent updates or the main updates coming in Java. So before answering, please make sure you're really using that version in your project and take a look of the main features you are using from that version. So as of now, I am sure you are using any version between Java 8 to 21. So the next set of questions on it is what are the new features in this version introduced? What are the features you used? Suppose if you are using Java 8, the questions will be what are lambda expressions, what are functional interfaces, and what are the use of streams. You know them well, right? And above Java 8, the questions will be like what are shell classes which are introduced in Java 17, and then for Java 19 like what are virtual threads which are introduced as part of project Lombok, right? And then like how the switch statement is supported for pattern matching in Java 21. I'm just highlighting only one of the important features from these versions. So here my intention for this question is to make you aware that you should go through the all important features introduced in your Java version whichever you are using or the recent versions. Similarly, other side I have just mentioned the Java 22 which was released in March 2024. Just listed the important features. You can take a note down of those which can be helpful and handy. Now let's jump to the next question. So the second question from Java is what methods you have used in project of optional class. I hope you well aware of with this optional class, right? Actually, this is a container object kind class. Usually we use this to avoid null checks and null pointer exceptions. So this container object may or may not have the null values in it. So let's say take an example of a class called student, which is a null object itself at runtime. But we don't know what actually it came from the DB. Then if we are trying to access any properties from it without checking the object for the null, then obviously we'll get a null pointer exception at runtime. Then it stops the execution for the remaining code from there, which is abnormal and we don't want it at runtime, right? So this is where optional class comes handy. There were two ways we can create an object using optional. Suppose if you want to create a string object, you can declare and initialize it using optional.off or optional.off null label. In the first case, it creates an optional with the specified non-null value, and in the second case, it creates an optional that may hold a null value. Here the key difference is, in the first case we know the value is not null, but in the second case we don't know at runtime what getValue method will return. So that's why the second variable may hold a null value. With the optional object, we have three methods, that is present, if present and get. Using isPresent method, we can check there is no null in the object and we can access the values in that object. Also, we can use get method along with if present to access the object and using it to print the value. And coming to the optional of nullable, it provides three methods, that is or else get and or else throw. So by those method names you can guess what they will do. Using or else, we can assign a default value to the object if the object is null or empty, and while accessing the same optional object using or else get, we can access the value safely. And finally, or else throw will help us to throw the runtime exception or the customized exception if there is no value present in the optional of nullable object. The optional of nullable also provides some more useful methods, that is filter, map and FlatMap. You might have heard the names of these methods in the Java streams, right? So here with optional also, these methods behaves the same. Filter method is used to filter the object based on defined criteria, and using map we can return the value, that is mapped value from the non-null object. Similar to the map function, FlatMap returns the optional value instead of returning the values from the original object. And the last notable point using optional is for streams, Java 9 and later, if a value is present in the optional object, it returns a sequential stream containing only that value. Otherwise, it returns an empty stream. Overall, I am putting one example here which we will use in our day-to-day projects for optional. Here in the first method, that is find user by ID, we are trying to fetch a user from the database, assuming user repository is connecting with the database. And in process user method, we are calling this find user by ID, and we are accessing and printing the username using if present or else safely. If user is present, we are printing user found with username, else user not found. So that is all about the optional class and the optional objects, which will be used for null checks and avoid the null pointer exceptions. So now let's move to the next question. This question is from Java streams. What is difference between map and FlatMap? So for these two, we can straight away remember what map does and what FlatMap does. If you want to transform a value from X to Y, then map is useful. So FlatMap returns always a single value. Okay. Whereas with FlatMap, along with the transformation, instead of returning a single value, again it will return a stream. So you can observe the same thing I have mentioned here with the 3 points for map and FlatMap. We can demo simple examples for map and FlatMap. Let's dive into them. Here in the first example, I have created a simple list of strings and I assigned 3 values: hello world, Java streams, FlatMap example. Here my use case is to collect all the words in those list values which are separated by the spaces. So using map, I am just trying to split and collect them, sentence.split and collector to list, right? So now when you try to print the collected list, it printed a list of array strings, because whenever you split a string using split, it always returns an array. So our resultant list, that is words array, contains the list of arrays. That is what it's printing instead of the plain strings. So coming to the FlatMap, you can see we're using the same operation, that is sentence.split with space, and we're collecting the list, and the return list is list of string, which means FlatMap returning the stream of strings here instead of single object or single value. So this is how map and FlatMap works with streams. Now let's jump into the next question. So here the question is about the databases and which kind of databases you are using in your project, that is on-prem or the cloud databases. So based on your DB in your project, you can answer this straightforward, and let us see what are on-premise and cloud databases. So the databases like MySQL, PostgreSQL, Oracle DB and some other relational databases comes under on-premise databases. Generally, these on-premise databases are hosted on physical servers within an organization's own data center. The organization has full control over the hardware, software and maintenance of the database. And they are not associated with any cloud platforms like AWS or Microsoft Azure. On the other hand, databases like Amazon RDS, Amazon DynamoDB, Google Cloud SQL are the cloud databases. These cloud databases are hosted on servers in data centers managed by cloud service providers like Amazon Web Services, AWS or Microsoft Azure or Google Cloud Platform. Here, the cloud provider is responsible for maintenance and hardware, while the user has control over the database management. Hope you get this answer well. Now let's jump into the next question. So here the question is how you are connecting to the database. Yeah, the actual question is how you connect to the database using JPA in a Spring application. So in a Spring application, following are the steps. If you are using Maven, then you need to add the Spring Boot starter data JPA in the pom.xml, or else if you are using the Gradle, then you need to add the same dependency in the Gradle file. Adding dependency is the very first step, and the second step is configuration of the data source. The data source object is nothing but it holds the properties to connect the database. So the properties are like database URL, username, password, the database driver class name, and other JPA properties, how it should behave. So on the screen currently you are seeing the application properties configuration. It's a .properties file. Spring also provides alternative way using the YAML file. So we can give the properties for the data source in the YAML file also. You can see the example here. I hope now you understood these two steps, how we can connect the database in a Spring application. I think now you are in a situation you can answer this question at any time. Let's move to the next one. This is again with the databases. How schemas are created in your project, manually or using any scripts. Basically, the schema is nothing but the structure of the tables and their relations. So as asked with the question, we can create the schemas in two ways, manually or using scripts. So the first step involves the design the schema, that is planning the tables, columns, relationships, indexes and constraints. So once the schema is planned and decided, then we'll write the SQL scripts to create those. And in the final step, we will run those scripts using a database management tool manually. So here I'm just popping up one example script to create a users table, and the table is having multiple columns like ID, username, email, password and created it. Also we have a script to create an index on the table using username, right? On the other hand, through the scripts, or we can say the auto scripts, okay? Actually, with this method also, we will create the SQL statements required. But here the key difference is we will not run those scripts manually using database tools. Instead, we will use some migration framework supported by Spring. One of the such framework is Flyway, and one more example of that kind is Liquibase. So let's see one example with the Flyway. Generally with Flyway, we will write the SQL scripts, and these files will be named in a specific way, like version numbers and the change you are making to the table. For example, here you can see I have three scripts created. The first one to create the table, second script is to insert the data, and the third one to modify the table. These scripts following specific sequence one after another in the name, right? That is version 1_1, 2 and 3. So in a Spring application, whenever we enable the Flyway, it will automatically create the Flyway schema history table, and it ensures that each script is executed only once and in the correct order. This is very important note if you are using a Flyway, so please make a note of this. Then you can just see how we can configure the Flyway in Spring. So that is all about the automatic scripting through Flyway. The similar kind of manner we can use the Liquibase also for the auto scripting. I'm just popping up the example here for the Liquibase. So whether it's a Flyway or the Liquibase, their motto is same, that is automating the scripts. Only difference is in their configuration and the way they control the scripts. So now let's move to the next question. Actually it's a follow-up question. How after adding properties in YAML, it connects to DB? How it creates configuration or beans internally? In the fifth question, we have seen that we are adding the dependencies, then we are providing the database connection properties to the data source through application properties or application YAML file, right? After this, whenever we are deploying or restarting the application, Spring tries to instantiate three main JPA objects, that is data source, entity manager factory and transaction manager. These are the three necessary beans to connect with DB and make transactions. So in a Spring application, these components work together seamlessly. Whenever you configure a JPA transaction manager, it will automatically look for an entity manager factory to manage the transactions for the JPA based resources. Similarly, the entity manager factory will use the configured data source to obtain connections to the database. I hope now you understood how these components will get created and how they work. Now let's move to the next question. So again, this question is the follow-up question. How to tell Spring Boot not to do auto configuration using properties from YAML and want to use JPA only but want to do them manually, okay? So previously what you are doing is you are just enabling the JPA and providing the properties to connect the database through data source, right? And data source being automatically getting created and it's connecting to the database. But here we want to avoid that and we need to make our own data source and connect it to the DB, okay? So for the manual configuration, we need to follow two steps again. The first step is to exclude auto configuration classes. So here we need to exclude the JPA auto configuration class in the Spring Boot main class. Okay. Then the second step is manually we need to configure the JPA beans. For that we need to create a configuration class to define beans for data source, entity manager factory and transaction manager. Right. These are the main required 3 JPA classes for us. Now let's do this to disable the Spring Boot auto configuration. So here the examples to demo that. You can see in the first step I'm excluding data source auto configuration class and Hibernate JPA auto configuration class. So when we exclude these classes, there is no way Spring can instantiate those respective data source and JPA classes, right? And in the second step, I'm just defining the beans, that is data source, entity manager factory and JPA transaction manager factory. So for this we have created a class JPA config using @configuration annotation, and inside that the first method will return a data source and we're instantiating this data source using the driver manager data source. Okay. So as usual we provide the properties required for the data source like database URL, username, password and the driver class, etc. Okay. Similarly, we have to define other kind of two beans, that is entity manager factory and JPA transaction manager. Okay, this is all about the manual configuration for Spring Data JPA. Now you can pause the video and take a small short break. Then we continue with the remaining questions. The next question is again from DB or JPA, and the question is what is difference between driver and dialect. So in the context of JPA, driver and dialect are two different aspects. Driver is useful to connect with the database, that is for the connectivity, executing the SQL queries and returning the results. Or in a layman language, you can say driver acts as a bridge between database and our Spring-based Java application. On the other side, a dialect in Hibernate refers to the class that represents a specific type of database. So it's like a language translator, right? Based on the data type, dialect is able to translate Hibernate queries into the specific SQL dialect understood by the database. A small visualization for the driver and dialect here, how the application and database works. You can see driver helps to connect and transport SQL queries and results, whereas dialect translate the JPA or Hibernate queries to the respective database queries. It's a simple translator, or you can say dialect knows the protocols of the respective database. That is all about the driver and dialect. Now let's move to the next question. Now we are moving to the next important topic, that is about the APIs. So the first question asked with the APIs is, if we are calling multiple different services, that is external services, then how we can call multiple other API services simultaneously from your service? Let me make you understand this question in another way. Suppose 3 external API calls are independent of each other, but in your use case you want to combine those results coming from the each service. Okay, then what is the best way to invoke those API calls, that is external API calls? If you are an experienced web developer, I hope you are able to sense the answer, right? We need to make a parallel calls and then we need to combine the results. To achieve this in Java, we have actually two ways. We can use the completable feature class provided by Java, and the second way is we can use reactive programming libraries like Project Reactor or RxJava. So let's go through the first example, that is completable feature provided by Java. Here along with the completable feature we required a web flux which is used to retrieve mono from the body. Here body refers to the response body that is we're getting from the API call, and from this mono class we can convert our response to the feature. I will give you that example in few seconds. Before that, here actually the web flux also belongs to the reactive programming, but here for our use case we are combining that with the completable feature provided by the Java. So after adding this dependency to our Spring application, let's write the code in the service class to call the external APIs. So here in the service class, I am just initializing the web client. In the constructor, web client is initialized with the external URL. Then I have declared 3 methods, that is call API1, call API2 and call API3. They are calling the same service but 3 different APIs from that. Okay. In all the methods, you can observe one thing. After making a call, it is retrieving the response and it's converting to the mono, right? Body to mono. Then we are converting that mono to the future. Then I have written one more method, call all the APIs, right? So here I'm just making the calls to the call API1, API2 and API3 and storing the result in the respective completable feature objects. Okay. So from these three API calls, we don't know which API responded first and which API is responded last. Okay, they are parallel and non-blocking calls to each other. So to collect and combine all these responses whenever they received, we need one more completable feature. That is what we have declared here in the highlighted box. This allFeatures.get method will wait for all features to be complete. Then it will combine the results and we can extract the each result. At the return, you can see finally we got the required strings from the external APIs and we're combining the result there. We can also shorten this call all APIs method using mono.zip to call all the external services at once. As I told earlier, this mono is from the reactive programming again. Hence, the mono.zip is again from the project reactor. Using mono.zip, we are calling the external APIs and we are combining them using the mono.zip. Then we are mapping them to the tuples. Then we are extracting the result from get tuple t1, get tuple t2 and tuple t3. Okay. So in summary, completable feature allows you to perform asynchronous calls and wait for all to complete using completable feature.allof. Whereas using project reactor, it utilizes reactive programming with mono and flux to handle asynchronous operations in a more declarative manner. We have seen how useful and handy they are. They are making 3 different calls in a single line, right? So both these methods helping us to call multiple REST APIs simultaneously and combine the results efficiently. Now let's move to the next question, and this question is again from APIs. What is difference between post, put, patch in terms of request comes to our service? So post, put and patch methods each serves a specific purpose in the context of RESTful API services. If you are Java backend developer or a web developer, definitely you would use this method at least one, right? So let's go through the differences of these methods once. Starting with the post method, it is used to create a new resource. The request body contains the data for the new resource to be created. Okay, and coming to the behavior of this method, a new resource is created on the server. The server is typically returns a status code of 201 created. Okay, and this post method is not idempotent. Idempotent means if we hit the same request multiple times, it should have the same effect or no effect. Okay, but here in case of post method, if you hit it multiple times, it will create that many number of resources. With the same request, since it creates a resource, so the resources can be duplicated. Hence, the post method is not at all idempotent. Coming to the next method, that is put. Put is used to update an existing resource or create a new resource if it does not exist. So it has dual purpose. Either it can create a new resource or it can update an existing resource. Here the important thing to observe with the put request is it contains the complete representation of the resource including the ID by which it can be identified. So the behavior of this method is it replaces the resource at the specified URI. If the resource exists, it is updated. Else if it doesn't exist, then a new resource will be created. So depending upon the runtime behavior, it can return 200, 204 or 201 HTTP codes. And we can say put method is a idempotent because multiple put requests with the same data will result in the same state of the resource, because the same resource representation has no effect. You can observe here with the sample resource, it is taking ID, name and email. So if you update the email for the same ID with the same email ID, it will have no effect, right? Moving to the patch method, it is used to apply partial modifications, say partial update of the resource. Unlike put method, instead of taking the entire resource, it will take only the required fields to update. Coming to the idempotency property, we can say patch is a idempotent method, but this again can vary based on the implementation. Multiple patch requests with the same changes will result in the same state of the resource. But we don't know at the runtime request, if the request varies, again it can change. But the standard is we have to implement the patch method in a idempotent way. Okay. Now let's move to the next question. This is one of the most important question and it has lot of subtopics to cover. And the question is what patterns you have used in your project for microservices. So usually in microservices we will use various design patterns, right? Such as communication patterns, data management patterns, fault tolerance and more. Here I am listing some of the key patterns that I or we use commonly in our projects, that is in microservices projects. In a microservices project, the most important one is the API gateway pattern, which acts as a single entry point for all client requests routing them to the appropriate microservices. It also handles cross-cutting concerns like authentication, logging, rate limiting, and load balancing. Here you can see in the diagram we have 4 microservices and there is a gateway before them. Whenever the request comes from the client, whether it's a mobile or desktop client, request go through the API gateway, then it routes the request to the respective microservices. One of the main advantages of the API gateway is clients no need to know the multiple URLs of the different microservices, right? If they know the gateway URL, they can call the respective API seamlessly. And coming to the next design pattern we generally use for the fault tolerance is circuit breaker pattern. It prevents cascading failures by stopping the invocation of a service that is likely to fail. Okay, suppose on heavy traffic, if one service fail, that should not affect all other services, right? This is where circuit breaker pattern is handy. You can go through it. I'm not exploring them in details here. And one more important design pattern in microservices architecture is service discovery pattern. This pattern allows services to find and communicate with each other without hard coding the network locations. It also enhances the scalability and flexibility and supports dynamic service registration and discovery. So simply you can say it's a central service where all the microservices will register, and whenever they want to call each other, they will just look up in this registry to call the respective service. Likewise, in microservices, we have other important design patterns like database per service pattern, event sourcing, sagas, transversal patterns, bulkhead pattern, and centralized configuration patterns. Really, all these are very important for the microservices architecture. You can explore them individually. Anyhow, I will cover all these in our upcoming tutorials. We have 3 more questions left. Let's move to the next one. And the question is which gateway you are using in your project. So you can tell whichever the gateway you are using for your project. Usually we'll use the Spring Cloud gateway for the microservices using the Spring Boot. So I'm explaining here the key features of the gateway here. Okay. So usually Spring Cloud gateway, it provides webflogs to build reactive scalable API gateways. Okay. Spring Cloud gateway also supports common aspects or concerns like routing, filters, predicates, resiliency, security, and extensibility. Extensibility is nothing but adding more custom filters to secure the routes. You can see a sample of a configuration for a Spring Cloud gateway. This is how usually we will define the routes. Every route we will just define an ID, we will give the URL. Here the predicates are used for route matching and decision making based on request attributes, whereas filters are used for modifying requests or response or for additional processing after route has been matched by the predicate. To explore in depth on Spring Cloud Gateway, you can go through this official URL provided by Spring. Now let's move on to the next question. This question is about one more design pattern from the microservices, that is load balancer. So the question is which load balancer you are using in your project. So generally we'll use different type of load balancers depending upon the deployment environment and the requirement of the project. From the Spring perspective, Spring Cloud also provides a load balancer called Spring Cloud Load Balancer. It works seamlessly with the Spring Cloud Netflix, Eureka, or Ribbon and other Spring components. Here Eureka is a service discovery client which is provided by the Spring Cloud Netflix or OSS, and the Ribbon is client-side load balancer. Here is the sample configuration for the Spring Cloud Load Balancer. You can go through. If you are using Kubernetes, it is also providing a native load balancer called Ingress. You can explore about that also. Or else if you have AWS environment, it supports elastic load balancing, ELB. This ELB has multiple types like application load balancer and network load balancer, and one more called classic load balancers. Basically these LBs are two types. One is software load balancing or the hardware load balancing. Okay, it's also a huge topic and you can explore about that. Now let's move on to our final question, that is number 15. This question is again on the load balancers, and the question is how this cloud load balancer actually balances the load. So usually what these load balancers do is they distribute incoming application or network traffic across multiple targets. Those can be servers or application instances to ensure no single server become overwhelmed or overloaded. So let's explore the mechanism of this load balancing. Generally, there were two kind of load balancers, that is hardware and software load balancers, and these software load balancers follow different algorithms. I have named here some of them, you can go through. I have also designed quick visualizations for some of these main algorithms like round robin, list connection, and list response time LBs. If you have around 3 to 5 years of experience, I don't think you require in-depth knowledge of these load balancers, but I recommend you to go through at least clear the basics of these load balancers and different algorithms, so you will be confident for these microservices patterns. And finally, coming to other topic, I have some more questions remaining from the Kafka or the messaging queue, but due to the time constraints, I am not able to explore on them in this video, but definitely we will cover that in the next episode. So please stay tuned with bitbee for exciting and upcoming real-time interview questions. If you found this exercise on Java Dev interviews, I recommend you to please help out the other community by submitting the interview questions to bitbee so that we can discuss them and we can help out everyone here. You can send the questions to mail mentioned here or showing on the screen, or also you can submit to a Google form I am providing in the description here below. Please kindly don't hesitate to submit and we need your support to continue. And please subscribe to the channel if you are not yet subscribed, and that is all about in this video. We'll see you in the next one.